Welcome to the video solution for Superquiz 1. This will be the solution for problem 1. In this problem, which is all about looking at the um, basics of sets, we're asked to indicate whether each of these statements is true or false, but of course the real interesting part is in justifying the answers, right? So seems that if somebody capitalizes something, it might be really important for you to do. So let's make sure we're doing that. Okay, let's read these questions. So the first one is giving us a set, and it contains the real numbers and the rational numbers. And I'm saying that a little bit ambiguously so as not to give away the answer immediately, but if we wanted to be very, very clear as we read this, we should be saying that this is the set containing as its elements the set of real numbers and the set of rational numbers. So this is a set that has two elements in it, right? So this set has two elements. Each element is in fact a set itself, but that's beside the point, right? Two elements. The set of reals and the set of rationals. Now, it's very important, right? It's not the reals which are in this set, but the set of reals. And there's a distinction between there, right? There's the set of something, and then there are the things in that set. And they're not the same thing typically. All right. So in this case, the cardinality of this set is actually not infinity, even though each one of these sets has an infinite number of elements inside of it. The cardinality of this set is actually just 2. So the answer in this case is going to be false. All right, let's look at this second one. The empty set is an element of every set. All right, well, we just saw a set that has two elements, the reals and the rationals, and neither of those two elements is the empty set. Now, that suggests that the answer to this should be false, and of course that's correct. It is false. What would have made this true? What would have made this true is if we got rid of an element and made a subset. So this is true. So if I have any set, call it, say, S, then the empty set is a subset of S. Why? Well, what does it mean to be a subset? That would mean that every element of the empty set is an element of S. And because the empty set has no elements, there is no condition to check. It's a vacuously true statement. All right, let's look at number 3 now. So A and B are sets, and the cardinality is equal to 28. So remember, this notation means there are 28 elements in the set A. B is another set with, now it has cardinality 16. And we know that the intersection, so remember this upside down U means the intersection from a pictorial point of view. Remember, this means if that's A and that's B, then this shaded region in between is A intersect B. So it's all the elements that are both in A and in B. And we're saying that that has 8 elements. So this A in total has 28 elements. This B in total has 16 elements. And then the intersection has 8 elements. Okay, and then the claim is that the cardinality of the union, so the union is going to be everything that shows up in A or in B, right? So this purple region, so the purple region. So the claim is that the cardinality of that set is 36. So it's possible that you know a formula for computing the union or the cardinality of a union. So I'll write down that formula because it's probably a useful one to know, but I'm not assuming you knew that for this problem. So the cardinality of a union is going to be the sum of the sizes of the individual sets minus the cardinality of the intersection, which in this case would be 28 plus 16 minus 8. All right, 44 minus 8 is 36. Okay, so the answer to this one should be true. Okay, but what if you didn't know this formula, which I assume is the case for most people? So you have to reason this thing out here. All right, so A has 28 elements in it. So we also know that 8 of those elements are also in B. So let me redraw the picture so that we don't have all the colors in our way. So we can have our A and we have our B. And we know that the cardinality of A is 28. But 8 of those elements we know lie in the middle. Okay, so 8 of them are in the intersection. So the remaining elements that are in A but not in the intersection, well, it must be 28 minus 8 of them. So there must be 20 plus 8 elements in A, or 28 elements. Okay, how about in B? Well, we know there are 16 elements in B, and 8 of them, again, lie in the intersection. So 8 lie in the middle, so there must be 8 remaining. And so in total, we have 20 plus 8 elements, which is 36. So that'll be the cardinality of the union. All right. How did we ultimately get? Anyway, how does one get this formula? Well, it's essentially right using the same sort of argument that we did to write down these numbers. All right. So let's say we knew this in general. We'll draw the picture again. So I know that in total I have the cardinality of A over here and the cardinality of B over here. If I want to compute how many lie on this side, I take the cardinality of A and I subtract how many are in the intersection. All right, so I did 28 total minus the 8 in the intersection. And for B, I can put over here this number of elements in B minus the number of elements in the intersection. And then, of course, in the middle, I have the number of elements in the intersection. If I add these all together, I have the cardinality of A minus the cardinality of the intersection plus the cardinality of the intersection plus the cardinality of B minus the cardinality of the intersection. And so in total, I have the cardinality of A, I have the cardinality of B, and then you notice here we have a minus cardinality of the intersection plus a cardinality of the intersection. That goes away, and I'm left with this minus the cardinality of the intersection. So that's how you could derive this formula if you want. Okay, I hope this is helpful.